Okay, we're going to be going over week 4 loops and array lists. So this slide here, loops, while loop, for loop, nested loop. So we open that up, it's going to look like this. I'm going to go through this. You should do this as well, pausing for coding examples so that you can practice this. And I'll say pause now and practice. So we'll go through this. All right, so our learning objectives are to understand how loops can control the flow of a program, execute statements repetitively using while loops and for loops, demonstrate while loop and for loop syntax and semantics, which are the meanings. So dealing with loops. Loops can allow us to do lots of things. While loop might say something like, in real life, while I have more photos, add them to my album. A for loop might be something like, for every number from 1 to 100, check if the number is even. So we do lots of things using loops. The key elements of a loop are we need to have an initial condition where we start, statements, what are we going to do each time, and a terminating condition, how do we know when to stop that loop. So it says here show Blockly level 4, we've done that. So it looks like this, it says while not done, move forward, turn left, move forward, turn right. So this is a while loop, and as long as we are not done, meaning finished up with this Blockly maze, we're going to continue moving forward and turning left. A while loop. Here is its syntax, while, and we have a condition. This is a Boolean expression that needs to be evaluated. As long as that is a true statement, we will go in here and execute these statements. While this condition is true, execute these statements. When this condition no longer becomes true, becomes false, we will exit and go to other code here. So here's something we can look at, an example. While there are more cookies, give one away. Okay, we're going to start with 6 cookies. While num cookies is greater than 1, we're going to print out here's a cookie, and then we're going to take 1 away from num cookies. So let's take a look at this. While it is greater than 1, so we'll see how many times you think this is going to print out here's a cookie. We're going to print out from 1. The num cookie will be then 5, 4, 3, 2, 1. 1 is no longer greater than 1, so I'm thinking it's going to print out 5 times. Okay, so here's the code for it, and I did a while loop in here, which we don't need that. So let's just check this out. So num cookies, while it's greater than 1, print out here's a cookie, take 1 away from num cookies. I think it's going to print out 5. 1, 2, 3, 4, 5. Correct. Now if I were to do this, less than or equal to, now it's going to maybe give me 6. 1, 2, 3, 4, 5, 6. It will. Okay, so thinking about these conditions in here will determine how many times we go inside that loop and execute those statements. Okay, next slide. Here's another one of, we start off count at 1. While count is less than or equal to 5, print count and then add 1 to that. What will be the output? Well, think about that. Count starts off at 1, so it's going to print 1. Add 1 to it, count becomes 2. Print off 2. Count becomes 3. Print off 3. Count becomes 4. Print off 4. Count becomes 5. 5 is still less than or equal to 5. So it'll print out 5. Then it becomes 6. Goes back up here. 6 is no longer less than or equal to 5, so it will exit this. So it should print out count 5 times. Here's an example of a cue to quit. So we have a scenario where we have a string that will take in anything at all because it's empty right now. While input does not equal cue, we will say to the user, enter something, cue to quit. Input whatever it is. So this is what it looks like here. So we have our scanner, while input does not equal cue, enter something, cue to quit. So I run it. I can enter anything. I can say apple, B-A-N-A-N-A-S. I could do anything. I could say like chair even. It does anything. And then finally when I hit Q, it will exit the loop and it will no longer ask me to enter something because it says Q to quit. Okay, what's going to be the following output for this? Remember modulus. This has to deal with our remainder. So we start off with a count variable set at 0. As long as count is less than or equal to 10, so it will get to 10. It will check to see if count is mod 2 is equal to 0. This is saying that if the number divided by 2 has a remainder of 0, that would mean, in other words, if the number is even. This is a good way of checking to see that it is even. And again, we have two equal signs here. Remember, we're not assigning value, we are checking value to see that it is the same. We're comparing, we're not assigning. So the output for this, let's take a look at it. All right, we have our count is less than or equal to 10. Start off at 0. Count mod 2, compare it to 0, print count. Add 1 to count. So right now we're going to print out the even, 0, 2, 4, 6, 8, 10. So this prints out the even numbers between 0 and 10. And the great thing about this, if I wanted to expand this to say 1,000, real quick, like it would print out all the even numbers to 1,000. That's how fast that is. So the neat thing about loops is that you can do things, use the power of computers to do a lot of repetition for you. Infinite loops. So this might be that we never reach our ending condition. So if this statement in here, that condition is true and it never gets to become false, that loop will continue forever. So here is an example of an infinite loop. I start off with the value num is equal to 1. While num is greater than 0, I'm going to print off num and then add 1 to that. So num will become 2, 3, 4, 5, etc., which all of those, when evaluated against whether or not it's greater than 0, will be true. So all of these will continue to be true. So it will still print this num forever. It'll say still going, and I did put in the num to kind of get an idea of how far it has gone. So if we look here, see still going, and we're getting into the 200,000, 300,000, 400,000, 500,000. It's going to go forever. Still going. Now to kill your application, you have this red stop. It says terminate. You want to do that, boom, and it dies. Otherwise, your computer will be locked up in an infinite loop. Like this right here. Here's that termination box. For loops. This is another way of iterating through some items. So we have our syntax for a for loop. Starts with the keyword for, and then we have our conditions here. So initialize a variable. Usually it's I equals something. Check to see how far I has gone to make sure that we have condition check. So I is less than or equal to or greater than or equal to some sort of value. And then we're going to increment I, if we use I, by a certain amount. And as long as this condition is true, we will go in here and do these statements. When this condition is no longer true, we will exit the for loop and try other code. So while loop versus for loop, these two will do the exact same thing. Start off with num equal 1. While num is less than or equal to 5, print num, add 1 to num. So it's going to start off in 1, 2, 3, 4, and 5. Prints off itself at the current value, adds 1 to it, checks to see that it is less than or equal to 5. It will not print 6, but it will print 5. In this particular case, we start off at 1. Same evaluation. The condition is that num will have to stop. Well, we will stop when num is no longer less than or equal to 5, and we're going to go up by 1, printing that. So those two will do the exact same thing, depending upon what you like best. Okay, here's something for multiples. So we print multiples from 3, print multiples of 3 from 3 to 300. So we can use modulus. So if it is divisible by 3, that means that it is a multiple of 3. So we will get that. So if the value at I divided by 3 equals 0, then print out I. So then it will evaluate every number in here because we're just going to go up by 1. So I will start off at 3. If 3 divided by 3 equals 0, which it does, we would print off I. So 3 would work. 3 then becomes 4. We add 1 to that. 4 divided by 3 does not have a remainder of 0. It has a remainder of like 1. So then it will continue to down this until I becomes like 6. 6 divided by 3 is equal to 2 with no remainder. So that would work. Here is one where you are going to just care about the multiples because we're going to be jumping through I a little bit faster. Instead of evaluating I at every single number, we are only going to jump by 3. So I starts off at 3. As long as we'll have the same condition where I can no longer, I needs to be less than or equal to 300. And then we're going to take I and add 3 to that. So we're going to start off at 3. Next, print off 3. We're going to add 3 to that, so it becomes 6. I becomes 6, print off 6. Add 3 to that, I becomes 9, print off 9. Okay, so that is that's how that will look here. So this one here is when we're going to evaluate every number. We get 3s all the way through to 300. 3, 6, 9, 12, 15, etc. And this one here is the same thing, only it's gonna have the exact same printout. 3, 6, 9, 12, 15, etc. Again, this one is evaluating every number. This one is just caring about the multiples. Now, let's try this one here. We'll take our, this will go from, this will do the opposite. This will start I at 300. As long as I is greater than or equal to 3, so it will stop at 3. We're going to take I and minus 3 from itself. And then we will print that off. So that looks like this. Start off at 300. As long as it is greater than or equal to 3, we continue to do this. We'll take 3 away from I. So we'll print this off. It'll start off at 300. Then we'll take 3 off of that to 297, 3 off of that to 294, etc. So this is how you can go from multiples from 3 down, from 300 down to 3. Okay, running sums here. We're going to try to compute the sum of integers from 20 to 70 inclusive. So it will include 20 and 70 is what it's saying. And then print the results. So this is going to be, these add up pretty fast in actuality because we start off with 3 variables, low at 20, high at 70, sum is 0 just to hold a value. So I is starting off at 20. As long as I is less than or equal to 70, which is high, we're going to go by 1. And we're going to take sum and add I to that. So the first time sum is 0, but we're going to have I as 20, so we add 20 to that. So then sum becomes 20. I goes up by 1, so it becomes 21. Then we add sum, which is 20, plus 21. So now we're at 41. Then we have it to 22. I becomes 22. Then we add 22 to 41, and we get 66 or something like that. So that's how, and then that will add up relatively quick. So that looks like this. Running sums. We have those 3 variables, low, high, and 0. And we're just going to add 1 to that. So let's see what that looks like here. Sum is 2,295. Now, if I were to put this print line inside here, we would see it adding up to 2295. It would do that all the way up. So we would do that one, starting off at 20, 20 plus I, and it jumps up. Okay, so then depending upon where you want to, if you want the printout to have all these values in there, you would put it inside the for loop. Otherwise, if you just wanted the answer at the end, you would put it right outside that first, right outside the for loop. Okay. Okay, so let's think. Compute the sum of even integers from 10 to 100 inclusive, and store the result in a variable called even sum. For the same range, compute the sum of odd numbers and store in a variable called odd sum. Print the results. Could be a good time right now to pause this up, go over to your Eclipse, and test your ability. All right, I'm sure that you've already done all the coding for this. I did pause for a second there, but I coded this up as well. Okay, so we're going to do even sum first right here. So I have 2 different methods for doing this. Like we learned earlier, we could evaluate using modulus, or you could evaluate using multiples or jumping through this. When you use modulus, you're going to evaluate every single number and seeing if it's even. When we're doing the multiples, we're just jumping by values, jumping by 2 to keep our multiples of 2. So in the first one, we start off at 10. As long as I start I at 10, as long as I is less than or equal to 100, we're going to go up by 1. If I divided by 2 has a remainder of 0, so I mod 2, its remainder, if it is 0, then we will add even sum. We'll add whatever I is to even sum, and then we will print that out here at the end. Another way of doing that is by jumping, starting I off at 10. making sure that I note does not get above 100. We're going to jump by 2, so it'll be printing off 10 plus 12 plus 14 plus 16, etc. So we run this here. We get 25, 30, and exactly the same number for both those, just two different methods of getting it across. Now we're going to do odd sum. So 25, 30. So odd sum should be 24, 75. Let's take a look at how odd sum. It's pretty close to the same. Not exactly, but pretty dang close to what we did before. Now, in this particular case, though, we're looking for whether or not it is odd. So in this particular one, I starts off at 10. As long as that value does not cross 100, we're going to add 1 to it. And we're going to evaluate I. If I mod 2, so if I divided by 2 has a remainder of 1, that would mean that it is an odd number. It is not even. It would have a remainder of 1. Then that would make it odd. And we're just simply taking that value and adding it to odd sum. So odd sum will start off at 0, and it'll add up all those odd integers together. Here's another way of doing that, just skipping through using multiples. But this time we can't start I off at 10 because 10 is not an odd number. We need to start off I at 11. And evaluate that it cannot cross 100, and we're going to add 2 to that. So starting off at 2, starting off at 11, we're going to print 11, or we're going to take 11, store it, add 13 to that 11, store that value, add 15 to that value, and store it, etc. And then we'll print them out. So either using modulus or multiples, we get 2475 using that route, which is what we were looking for. All right, strings and loops. Let's see, so we have string input of string. We're going to go through using our dot operator of length. So we're going to go store value of string in the variable string variable input. It will be a string, is what's stored in there. Start I off at 0, so that's an index value. As long as input dot length, which is the length of this string, I doesn't cross that, we're going to add 1 to it, and we're going to print line the character at I. So we're going to start off using I as an index. So printing off A at index 1, printing off space at A at index 0, printing off space at index 1, printing off S at index 2, T at index 3, R at index 4, etc. So it'll look like this. So I did 2 here. The next one is also coming up here soon. So I'm going to hold that off right now. Okay, so for that, what it does here is it says a string, and it prints them by line. Now, if I were to do just print, it would put them in a row here, a string, just like that. And then adding on this here too, which is not necessary. So I want them to print line and then just go down horizontally, vertically along the side. That's what it's asking to do. Our next example is strings and loops. We're taking the name string ARNON. We have another string name that has nothing in it. We're going to start off at index 0. We're going to go to name.length, which is this variable here, ARNON. As long as I does not get longer than the index at the end of that string name Aaron, we're going to add 2 to that. So we're going to jump by 2. So it's going to print off 0, and then index 2, then index 4, then index 6. It's going to store those in our new name variable and then print that out at the end. So it will skip, so it should be printing every other character. So let's test that out here. Okay. It did. So I printed out every other character, and if we start A, N, N, that's how you get that there. Okay, so they can print off every other character for that. Okay, so here we go. Another chance for you to think around using strings. So you want to write a for loop that reverses the string and stores the result into a new string. So we need to have these starting off a string word and a string reverse with nothing in that. We're going to use spoons. You could try other strings as well, and we're going to reverse this. So I'm going to give you a second to think about that, and I will be back with the code in just a moment. Okay, hoping that you figured this out, but we don't necessarily need to always start off at the beginning when we do a for loop. We could start at the end and then work our way backwards. That's going to be the easiest way to do this particular code right here. So what we're going to start off with is a string variable called word with spoons stored in that. We have an empty string called reverse. Now we're going to go into a for loop, and we're going to go off of this first word dot length. So as long as we're going to start I there at word dot length, so I is going to be way down here at the end, -1. So that's because we'd have index and length are 1 off. We're going to make sure that I does not get, it will get down to 0, but not below that, and we're going to -1 from I each time. So we're going to start off at the very end of the word, and we're going to store that value at that index in the word reverse, and we're going to print that out. So spoons becomes snoops. So we start at the end, and we, instead of adding to I, we're taking away from I, making sure that we don't get past the 0 index. Nested loops. In this particular one here, the body of a loop can contain another loop. So we have multiple conditions being met. So we have the for loop on the outside and a for loop on the inside. For each iteration of the outer loop, the inner loop iterates completely. So if we have this condition will be met entirely, and then exited out, backing up and checking this condition, adding 1 to this value here, and then going back in and completing the internal loop. So these have a lot of different abilities to do things, and just remember though, the workhorse is the inner loop, and the outer loop kind of just guides that work being done. So here's an example here. We have a nested for loop. How many times is I'm here going to be printed? Well, let's figure that out. If we want to start off with the outside loop, we have an evaluation, some conditions. I can't be larger than 10. Actually, 9 is less than 10. J starts off at 0 on this inner loop. As long as J is less than 10, we're going to add 1 to that. So we're going to come in here, and we're going to print off I'm here 9 times. Come back out. I will then be 1. We're going to come back in here and print off that 9 more times. Then I becomes 2. Going into the inside loop, printing this off again 9 more times, and etc. So it will print off a bunch. Let's have a chance to think about that, code that up. How many times do you think that I'm here will be printed? Okay, so if we're going from 0 to 9, that is 10 times running on the inside, and 0 to 10 is 10 times running on the outside. So if you came up with 100 I'm here's, that is correct. So here's what the code looks like. Let's run it real fast here. We have count being 0. I did throw this counter in here just to help out a little bit with tracking it, and it did come up to 100. If I run this one more time, it does. So we have 10 inside loops, 10 outside loops, so 10 times 10 is 100. Okay, here's one. This is a more complicated one, but we can figure this out. We have a nested for loop, and we're going to figure out what this prints out. Okay, n is 10. All right, so that's the farthest it's going to go. N will no longer, we cannot get to 10. So 0 through 9 is going to be our outside loop, and 0 through 9 is going to be our inside loop as well. So we go to the inside loop, and we're going to take I times j, and then add a space to it. And we're going to print these, so it's going to be printing vertically. Okay, so right now, I is 0, j is 0, so we're going to print a vertical line of zeros. Great. Next is, then we're going to have everything be incremented up a bit. So I becomes 1. J becomes 1 as well. And, well, wait, so we're going to go through and have, the reason we have a row of zeros is because I is 0. J will actually go 0 through 9. But timesing anything by 0 will give you that 0 value. So we'll have that horizontal, that vertical line of zeros because of that. Next thing, so I is 1. j will go from 0 to 9. So it'll be 1 times 0 through 9. So your second vertical column will be numbers 0 through 9. Then we're going to come back out here. I will then be 2. So then we're going to have our third column will be 2 times 0 through 9. So 2 times 0 is 0, 2 times 2 is 1, and then it'll be 2, 4, 6, 8, etc. And these are all, again, going to be vertically printed because we're using the print line features. And so it will do a bunch of vertical columns. So this is what it should look like when we print it out. Okay, so you have your vertical column as zeros. And then when I becomes 1, it'll be 1 times the integers 0 through 9. So 1 times the integers 0 through 9 will be that second column. Then this will be 2 times integers 0 through 9. 2 times integers 0 through 9. Then 3 times integers 0 through 9. So 3 times 0 through 9. 4 times 0 through 9. 5 times 0 through 9. 6, 7, 8, 9. 9 times 9 through 9. 0 through 9. Okay. Think, pair, share. What does the following nested loop print? All right, cool. So we have 5 rows, max 5 rows. Okay, row is starting off at the max level, and as long as row is going to be greater than 0, which would be 1, we're going to go down. So we'll have row 5, row 4, 3, 2, and 1, I'm thinking. So, and then we're going to print out stars. And it is a print, so these are going to go horizontally. I mean vertically. I get those vertical stars. All right, let's take a look at that. All right, run that. So we're going to start off with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0 through 9 is 10. Then we're going to take 1 away from that. Then it becomes, row will then turn into 9, then 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1. And 1 is still greater than 0, but, and we will, that's as low as we can go. All right, so that's a little bit about your loops, your for loop, your while loop, and your nested loop. Thank you.